let's go over to our main form and let's look at the design, and let's look at the leap year code. And we're going to cheat here a little bit, and we're going to create something called int year. And we're going to lie and say year equals 2012. And then we're going to say we're going to create an object of class myDates. No, we're going to do it this way. All right. Now, I've taken a shortcut here because rather than process what they typed into the text box, I'm just going to pretend that they typed it in, and what they typed in was 2012. I'll assign it to a temporary variable called year, and then I'll call the constructor. All right, now let's set a breakpoint right here, and let's run our program. And I click on leap year, and you can see we're down at our breakpoint. This particular button says advance to the next line without doing any routine calls. There are none, so it wouldn't have anyway. So now we go down to the next line. Now watch what happens when I click on this, which says to go into that particular section of code. Because I used the year as an argument to this instantiation constructor, it picks the second one. Now watch what happens when I advance. It goes to the first constructor and it fills in the myDate object. And you can look at myDate and you can see what it's done in terms of filling in the date and the time and the hour and so forth. Okay? So go up, single step out of this. It comes back to the constructor, and it now goes over and overwrites the year variable to 2012. All right? Now let's go back. Let's stop the program. Let's go back to our code. And let's change this. We'll duplicate this line so we don't have to retype it. And then we'll comment this out. And we'll change this to the non-constructor form. Now let's rerun the program. We come down. We go and step into the class date function. And notice it picks out the correct constructor. And it initializes myDate to the current date and time. Okay? So we have the ability then to use more than one constructor based upon what our desires are. Now, when would you use an overridden constructor? Well, this is a simple example, but for example, I wrote some software one time that had to do with a club in Indianapolis, and almost 99.9% of the membership was from the city of Indianapolis. Well, I had a class called Class Members, and in there was the city and the state. I had the constructor fill in the class city and state properties with Indianapolis, Indiana. That way, when I showed the form, I could fill those forms in with the city and the state and save whoever is running the program a little time. So one of the advantages of having multiple constructors possibility is you can set default values that you think might be typical when the program is run. So always keep in mind then that the constructor is what's used to instantiate the object in the first place. And if you think that there's going to be values for the properties that most of the use of the variable is not going to change. You might as well put it in a constructor and save the person who's entering the data typing of that particular information. All right, now let's go back to our code because we kind of cheated on that. So we'll get rid of that breakpoint. We'll get rid of this code. We'll get rid of this code. And we'll leave it with the non-initiated constructor. Now, if I really want to write this code the proper way, I need a Boolean flag variable. I need an int year. Try parse, if you'll recall, is simply a routine that's built into the integer object. All of the data types in Java, C#, C++, those are actually, even though they're value types, they're actually objects, and you have methods available for them. One of them for C# is try parse. And all it does is it gives you a very simplified way of checking to see if whatever the user typed in, to see if it does fit the specifications for an integer data type. So I'm going to take the text box that we're using, which was text year, and I want to go and fetch the text property, and I want to check whatever they typed in and see if it conforms to an integer. The keyword out here is necessary because Microsoft won't allow you to pass into a method any variable that isn't initialized to something other than 0. Well, to an uninitialized variable. Actually, the compiler will initialize year to 0, but this forces you to put the word out before it. That allows you to take year, even though it hasn't been assigned anything, and use it in this expression. Flag is returned from this int parse call. And if it's true, that means that it does conform to what an integer is. So we say if flag equals false, that means something went wrong. So we're going to take the message box and we're going to show the user a message, and we're going to say does not conform to an integer. Redo. Oops, I misspelled false. So now that message box is going to pop up and tell them that they typed in something erroneous. And what we really should do at this point is probably make them type it in. So we'll do text year again, and we'll set the focus to that particular text box. If there were multiple text boxes, this would make sure that we go to the right one. And then we're going to return and force them to go back and retype it. So if we pass this little check, that means at least we have an integer number, and chances are it might be a good one. All right. Since we know that year now, we have filled in year with whatever the user typed in, and we know that that particular piece of information conforms to an integer data type. So we can take year now and pass it into our overridden constructor that is willing to accept year as one of the date parameters. Now, when that comes back, my date will exist as an object in my program, so I can do something with my date. So if I type in my date and a dot, you'll see right now that the only methods that I have available to me are equals, get hash code, get type, and toString, none of which are terribly useful to me. Now watch what happens if I do something stupid, like putting public in front of int day. Recall our discussion. If I put the word public in front of a property, you should recall that that makes this thing visible everywhere in the program. So now if I go back to main and I type in my date period, note what happened. Day now becomes visible. Day becomes a property that I can directly manipulate from this point in the program. And you say, hey, that's kind of cool. No, it's not cool. It's horrible. And the reason is because now I've exposed a property to the outside world that they are free to change to whatever they want without me knowing about it, me being the code that I write in class date. In other words, that word public in front of day in the class violates the very basic principle of object-oriented programming, and that is encapsulation. We want to hide the data. Obviously, we're not hiding it when we do it this way. So we go back and we say, well, that's a really bad idea. So let's leave it as private, because when I do private, I come back over here, I type in my day. Now you notice that the list of things that the compiler knows about does not include access to the day property, and that's a good thing. But it doesn't have access to any of the other properties either. So if that's the case, I don't have a mechanism by which I can change the state of the object. Because remember, the only way to change the state of an object is to change one of its properties. So we say, okay, back to dates. If we want to be able to change the state of a property that's in a class, the best way to do it is to write a property method. Now, if I type in the word prop and do tab, it fills in what is called a skeleton for a property method. Remember when I talked about getters and setters? Guess what these two guys are? Those are going to be the getter and setter methods for this particular property. And this is just a generic name that Microsoft throws in for any property that you're about to enter. And you'll note the access specifier is set to public, which is a good thing, because now what we're going to do is we're going to expose the year property to the outside world, but we're going to do it in a way that allows us to make sure that they entered something sensible. All right, so let's type in the name as capital year. And because it's uppercase but my property is lowercase, there will be no confusion as to which is which. C# and most other languages, Java and so forth, are case sensitive. I do not like to use the single line form for getters and setters, so I'm going to do the long form because I think it makes it easier to read the code. Now, as you might guess, the purpose of a get is to do nothing but to retrieve the current state of a property from the class. So all I have to type in here is return year. And what that's going to let me do then is to access that particular property. Now note, if I go over here to main and I type in get year, notice what's appeared down here. I now have a property method defined that allows me to have access to the property named year. So I come back over here. And you can write whatever check you think is valid for a year that might come into the system. if you're writing something that has to do with property taxes or income taxes or something like that, I know that federal income taxes, for example, didn't come in until 1914, so I'm going to say if value greater than 1914 and value less than 2100, I'm going to assume it's a valid date. So to do that, I'm going to say year equals value. Else year equals 0. And here what I'm using is 0 as an invalid value. So I might comment that and say assume 0 year invalid data. All right. Now let's go back to main. And I can see that year so let's run this program and see what happens here. So what we'll do now is we'll type in the current year and we'll click on leap year and we immediately go to our breakpoint. Now up here you'll notice that flag is true, which means that we passed the test, so we bypass the message box, and now we're down here to where we're going to call our class to actually instantiate the object. So we step into it. We notice that we get passed in. The year is 2012 that we're passing in. We then go and we initialize the other members by the call to datetime.now. So now we also know that not only has year been set, but so has my day and my month. We come back. Year is now properly set to 2012. We go back to the caller. And now we are going to duplicate. We're going to recall the same thing. But this time, rather than using the default year here, we're going to take what they entered and reassign it into year, even though it's already been set. I want to show you how this works. So what we're going to do is we're going to single step and go into the property method that we just ran. And here you can see that we're doing a set operation. And if I single step, value is the value that was passed into the property method, in this case 2012. It's greater than 1914, it's less than 2100, so we end up setting the year to the value that's been passed in. And we come back, and now we can see that my date year has been set to 2012. Now the question that you might be asking, or you should be asking yourself, where did this come from? Nowhere do you see the word value defined in this section of code. And what's interesting about property methods is all of them will have a variable named value. And the type of value is determined by the type specifier for the property. So in this case, value is going to be an integer variable. And in this particular case, the value that's passed in is 2012, and that's what value is. I refer to value as a ghost variable. It's a variable that is defined in the program by the compiler, and it's used as a mechanism for passing information between property methods. It's only used in property methods. If I had put string here, if I said public string year, value would be a string variable. If it were a double, value would be a double. So value always assumes the type specifier that you use for the property method itself. All right? So when we call this, this is exactly what happened. Year ends up becoming value, and that gets passed into the class. And the advantage of using the property method is now I can check it. I can benchmark it. I can do something with it before I set it to the property in the class itself. When I made year up here, when I made this a public method, let me undo that. When I set this using a public method, I had no control over what they wrote in there. They could write 0, they could write 5,210, and I would not be able to say anything about its value. So that's what the whole idea of encapsulation is. You use the property methods to protect the integrity of the data that is inside the class itself.